Welcome to this video on the empirical rule, a powerful tool that helps us understand how data is distributed in a normal distribution, which is a bell-shaped, symmetric, and unimodal distribution. Symmetric because it's a mirror image of itself when it's cut in the middle. Unimodal means it has one mode or peak located at the center. The mean, median, and mode are all equal and are the center of the distribution. So we often just refer to the mean. Because of symmetry, 50% of the distribution is below the mean, so we have 50% above the mean as well. So what is the empirical rule? Also known as the 68-95-99.7 rule, the empirical rule states that for a normal distribution or for bell-shaped curves, approximately 68% of the data falls within one standard deviation of the mean. Approximately 95% of the data falls within two standard deviations of the mean, and approximately 99.7% of the data falls within three standard deviations of the mean. In statistics, we call this number of standard deviations z-scores. So when we say that 95% of data falls within two standard deviations, is the same as saying those values have z-scores between -2 and +2. Within one standard deviation of the mean, symmetry gives us 68% split evenly into 34% on each side. That leaves 16% in each tail beyond that range. Within two standard deviations, the 95% is divided into 47.5% below and above the mean, leaving 2.5% in each tail. Within three standard deviations, the 99.7 breaks into about 49.85% on each side of the mean, leaving only 0.15% in each tail. Now consider this example where lifespan of light bulbs is approximately normal with a mean of 50 weeks and a standard deviation of 5 weeks. We'll use this scenario to answer the following questions. On the horizontal line under the curve, the mean of 50 sits right here in the center. As we move above the mean in increments of the standard deviation 5, we hit our markers at 55, 60, and 65. This represents 1, 2, and 3 standard deviations above the mean respectively. Doing the same on the left, we subtract 5 for each step, giving us 45, 40, and 35 for our 3 standard deviations below the mean. Now for our first question. We need the percentage of bulbs that last between 50 and 60 weeks. We already know that the range from 40 to 60 are within 2 standard deviations, which represent approximately 95% of the data. Due to symmetry, the section from 50 to 60 is exactly the right half of the 95% block. So we divide 95% by 2 to get 47.5%. Next, for question 2, let's find the percentage of bulbs that last less than 60 weeks. Since 50 is our mean, we automatically know that 50% of the bulbs fall below that mark. We also know from our last problem that the area from 50 up to 60 adds another 47.5%. Combining these two sections, we find that 97.5% of all light bulbs are expected to last less than 60 weeks. Next, in question 3, we want to find the percentage between 40 and 55 weeks. Let's split the range at our mean of 50. To the left, since 40 is 2 standard deviations below the mean, this area is half of 95%, which gives us 47.5%. Now to the right, since 55 is exactly 1 standard deviation above the mean, this area is half of 68%, which is 34%. Adding those two slices together tells us that approximately 81.5% of the light bulbs last between 40 and 55 weeks. Next, question 4 asks, what percentage of the bulbs last longer than 65 weeks? Observe that 65 is exactly 3 standard deviations above the mean. According to the empirical rule, 99.7% of all data falls within 3 standard deviations. This leaves only 0.3% in the two tails. Due to symmetry, we divide that in half to obtain a tiny 0.15% of bulbs lasting longer than 65 weeks. For question 5, what percentage of the light bulbs last less than 35 weeks or longer than 60 weeks? The word "or" implies we need to find the size of these two separate tail areas and add them together. Let's start with the left side. 35 is exactly 3 standard deviations below our mean. Therefore, as seen in previous problem, the area below 8 is 0.15%. On the right, 60 is 2 standard deviations out, so we have a tail area of 2.5%. Finally, we combine them to get a total of 2.65%. Question 6 is a classic logic trap you might see on an exam. It asks for the percentage of bulbs that last less than 45 and more than 55 weeks. In statistics, "and" refers to the intersection, the place where two conditions meet or overlap. Because a value cannot exist in these two different tails simultaneously, there is no overlap. That is, there is no such thing as a bulb that lasts less than 45 weeks and at the same time longer than 55 weeks. Therefore, our probability is exactly 0%. Note that if we add the word "or" here, we will be adding the two tail areas to obtain 32%. Question 7. What is the lifespan below which only 2.5% of the bulbs fall? We're looking for a specific value based on a percentage. From the empirical rule, we know that the area within 2 standard deviations of the mean is 95%. The area left over in the lower tail is 2.5%. This tells us our cutoff is 2 standard deviations below the mean, which corresponds to 40 weeks here. So a lifespan of 40 weeks is the threshold where only the bottom 2.5% of bulbs remain. Next, question 8 asks, approximately what lifespan represents the 84th percentile? Remember, a percentile is just the percentage of data that falls at or below a certain value. We can start with the bottom half of the curve, which is 50%. To get 84%, we need another 34%. Based on the empirical rule, we know that 34%, which is half of our 68%, is exactly the area between the mean and 1 standard deviation above it. That gives us 55 weeks. So if a light bulb lasts 55 weeks, it lasted longer than 84% of all other bulbs. Next, let's look at a batch of 2,000 bulbs. How many will last longer than 55 weeks? We know that 50% of the bulbs are above the mean. From the mean to 55 weeks is 1 standard deviation, which we know covers 34%. If we subtract that 34% from the upper half of the curve, we're left with 16% in the tail. To get a final answer, we simply multiply 2,000 times 0.16, which gives 320 bulbs. Our final question is a type of conditional probability. We're only interested in the bulbs that last less than 55 weeks. Since 55 is 1 standard deviation above the mean, this subset of bulbs account for 84% of the distribution. Now, looking only at the 84%, what portion of them lasts more than 45 weeks? Recall that the range between 45 and 55 is our classic 68% window. Since we're comparing that 68% to our limited group of 84%, we simply divide 68% by 84%, which gives roughly 81%. And that's how to analyze specific segments of a population. As we wrap up, let's review the entire empirical rule in slices under the normal curve. Starting at the center, the 68% of data within 1 standard deviation of the mean is split evenly into 34% on each side. Moving out between 1 standard deviation and 2 standard deviations, we capture 95% minus 68%. That's another 27% of the data, which splits into 13.5% on each side. Between 2 and 3 standard deviations, we have 99.7% minus 95%, which is 4.7%. That is 2.35% on each side. Beyond 3 standard deviations, we have 0.3%, so only 0.15% of values fall in each tail. These are the rare extreme outcomes. And that's the empirical rule in one picture. Thanks for watching.